Hello, hello. So, good evening, everyone. Welcome to the live session 9 of this course in non-conventional energy resources. And it's already 7:11. So, I think if there are no questions from your side, then I think we should proceed with the session. So, let me, if my voice is clear, audible, you can please, can anyone confirm in the chat box? Okay, so I presume that I'm audible to you all. Okay, so let me share my screen then. The numerical question in week 7 of successive gear ratio, how to solve it? Okay, Faisal, we'll discuss that question, gear ratio, successive gear ratio. It's not a very hard question or anything. I will try to solve it, okay? Solve it for, I think this is from this course assignment. So I haven't seen the question, but I will try. And generally, gear ratio are basically there are two gears. So I'll show it how to solve it. I think you can also solve it if uh, I am not audible to you. Are you sure? Okay, so what should I do then? Am I audible now? Hello? Uh, am I audible or is there any issue with the mic? Can you confirm, Faisal? No, everything is working fine, huh? Yeah, everything is working fine here. Okay. So that gear ratio question I will try to solve. I haven't seen the question. So gear ratio generally I will give you the concept. You can even attempt from yourself also. Okay. So let me start. Yes, should I start? It's okay. So everything getting recorded. Okay, so once again, welcome you all to this live session 9 of NA course Non-Conventional Energy Resources. Today is 4th of April, and this course is basically taught by Professor Pratap Haridas. He is a professor in IIT Madras, and I am Rohit. I will be taking this live session in which I will be discussing various concepts related to the weekly lecture, that is week 9, and then we will go through the assignment questions. First, the non-graded question of the assignment will be taken, and then after that, we will take the graded assignment questions. If there are any queries in between, you will please feel free to ask in the chat box, and I will try to solve that query. Like Faisal has asked something about this gear ratio, so I will give you the concept. You can even attempt the question yourself also. Okay, so that's not a big issue. So yeah, everything, nobody wants to join. So yeah, we can proceed with the session. So the first question is about the use of biomass. So uh, first question says use of biomass represents the capture and release of the same amount of carbon, hence is considered safe for the environment. So if there are any queries, yeah, Faisal, please say. Am I? Okay, so if there are no issues, let me check if the mic is on or not. Okay, if there are no issues, then let us proceed with the session then. The first question says the about the use of biomass represent the capture, release, and release the same amount of carbon, hence is considered safe for the environment. First, we need to know what is biomass and what it is talking about capture and release. Okay, and then we'll talk about something called carbon cycle. Basically, for the we will take an example of a tree so that you guys can be more and more uh, familiar with what this question is saying. Okay, so it is saying biomass. So we'll see what can be termed as biomass, and use of biomass basically represents the capture and release of the same amount of carbon, hence is considered safe for the environment. Okay, so yeah. Biomass basically is carbonaceous content, like some organic content that some material which contains carbon, basically that can be termed as biomass. Okay, and it can be living, non-living form. Okay, so there are many definitions for biomass. You can take anyone, assume anyone. Okay, otherwise we'll take. If there is someone, let me see. Seems like okay. So yeah, where were we? We were discussing about biomass thing. Okay, so what happens? Yeah, this statement is actually true. We'll see how. So let us assume tree as a biomass. Okay, so there is a small plant, and this small plant actually absorbs carbon from the cycle. It absorbs CO2, convert it into starch, and this plant grows into this tree. Okay, so what happens when this plant is actually converting the carbon into it is actually storing the carbon from atmosphere. When you burn this tree, whatever carbon is stored throughout its life is actually released to the atmosphere as CO2. Back to the atmosphere. So what this question essentially says, use of biomass represents the capture and release of the same amount of carbon, hence is considered safe for the environment. So what it did, it removed the same specific amount of carbon, and when you burn it, it releases the same amount of carbon to the atmosphere. So it doesn't contribute anything extra to the environment. Only the carbon which it has stored itself that has been removed from the atmosphere, it contributed back to the environment. So that this question is considering. So, so this can be considered safe. Why safe? Because it is not contributing any extra carbon to the atmosphere. Okay, so that's why this statement is actually true statement. Now there are several definitions of biomass. So I have tried to compile it with some authentic source to give you guys a basic idea about biomass. So first thing is that ki biomass is renewable organic material Renewable means it can be renewed. Organic means something which contains carbon that comes from plants and animals. Okay. Biomass continues to be an important fuel in many countries, especially for cooking. Like in India, we use biomass for cooking and heating in developing countries. Like in, I can't say developing, even the developed country also use it for heating. Like Canada or Russia, they have houses made up of central heating system which burns biomass to keep the house warm in the winter. The use of biomass fuel for transportation and for electricity generation is increasing in many developed countries as a means of avoiding carbon dioxide emissions from fossil fuels. The use of biomass fuels. Okay, so what can be biomass fuel? Something that is derived from biomass, like even the biodiesel is biomass fuel can be termed as. For transportation, electricity generation is increasing in many developed countries as a means of avoiding carbon dioxide emissions from fossil fuel users. Because fossil fuel use contribute a lot to the atmosphere, carbon dioxide, NOx, SOx, PM. But when you burn these biomass, these only contribute that much amount of carbon dioxide which it has removed from the atmosphere itself. So it can be termed as carbon negative. Okay, zero carbon. This term is very important, or it contributes zero carbon to the atmosphere. Okay, so I have given a data of 2021. Biomass provided nearly 5 quadrillion BTU, that is British thermal units, and about 5% of the total primary energy used in US. So where the most of the energy usage was gone for cooking and heating. In US mostly it is gone for heating only. And biomass contains stored chemical energy from the sun, so it doesn't have any specific energy. It is basically the chemical energy that is stored with from the sun is actually seen as biomass. Biomass can be burned directly for heat or converted to renewable liquid and gaseous fuel through various processes. So yeah, it there are various processes. Since the lecture doesn't discuss those processes specifically, but processes like combustion, pyrolysis, gasification are very much which actually convert biomass to various renewable fuels. So can be burned directly for heat, that is combustion. Second is are converted to renewable fuel and liquid gaseous fuel through various processes. Okay, so these two things are there. So so one thing is that the photosynthesis process can be used for converting the radiant energy from sun. So radiant energy that is coming from in form of radiation or something, and to chemical energy in the form of glucose or sugar. Okay. So what is basically photosynthesis? It takes six water molecules, six CO2 molecules, and then we have the sunlight. So there is a pigment called chlorophyll. And, okay, radiant energy, then it is converted to glucose and oxygen. So this is basically a glucose molecule C6H12O6, It is basically stored in the form of starch, and this can be utilized further by burning it. So you obtain when you burn something like in combustion, you have CO2 and H2 as the major product. So what can be different types of biomass that can be utilized for energy? So one thing is that wood is there, crops and agricultural residues are there, vegetable oils and fats are there, trash and garbage are there, sewage is there, and animal manure is there. So all these things can be termed as biomass. So there can be many n number of things that can be termed as biomass depending on the even if you consider solid waste, municipal solid waste. So not everything can be termed as biomass. Like plastics are basically polymers. So most of the parts like food waste, these can be considered biomass. Okay, wood, all these things. Okay, so this whole slide is actually very much a representation of this biomass thing, where you get a good idea or good sense about how this biomass is actually termed as renewable. Why it is renewable? The main thing is that it is something which can be grown very fast, like in a span of 10 or 20 years. And second thing is that it is not using any fossil fuel thing. It is basically storing the energy from the sun in chemical form, that is glucose, and in the process it also generates oxygen. Another thing is that when you use this radiant energy from sun, so radiant energy from sun is unlimited. Why it is unlimited? So sun has a lifespan of something 4.5 or 5 billion years. That is a quite a huge amount of lifetime that can be utilized for storing this energy and converting it to the chemical form. Okay, so I think the concept of biomass and this question is clear to you all. So let me see if somebody wants to join. Okay, nobody wants to join. So yeah, if there are any inquiries or anything you wanted to ask about this biomass thing, please feel free to ask. So all these things comprise a typical term that can be constituted as a biomass. So question two is basically temperature deep inside ocean is relatively changed by the time of the day. So uh, this is something deep inside ocean is relatively changed by the time of the day. So this question basically talks about the temperature variation that goes into the sea. So when you see a temperature variation in the sea, so a stark variation can be seen, and it's not like a uniform temperature distribution inside the sea for different time of the month and different time of the day also. So it varies basically. The lower layer of the sea is basically uh, very deep. So when you're talking about deep inside the ocean, so basically when you go for deep inside the ocean, the sun rays cannot penetrate to that depth. So what happens when sun rays cannot penetrate to depth and upper layer is actually warm. So what happens? This heat inside the this deep inside the ocean is actually preserved, and it's kind of no sunlight or any energy is reaching to the lower depths. So that's why this lower layer has a temperature that is relatively unchanged, and even if it's day or night, the temperature relatively very much stable throughout the day. So it's basically a true statement. So it's quite true. In the upcoming slides, we will see that how this temperature is actually not varying. I will show you the variation of temperature throughout the ocean, and you will be able to actually figure out the things yourself, like how this temperature is changing, how it can be termed, how throughout the year or something. So I've taken the various graphs from different sources to make you understand about this temperature thing inside the ocean. So yeah, let's move to the next slide to see the variation of temperature by depth. So let's see, as of now this is the sea surface, these are waves. So this can be termed as zero surface. Then we go to 200 like something. So there is like if this is 25 degrees Celsius. So since upper layer has uh, penetration of sunlight, so this upper layer generally up to depth of 200 meter is generally warm. There is the temperature is mostly equal to the temperature of the surface. So okay, this surface layer has not seen a much variation temperature as can be seen from the graph itself. After this upper layer there is thermocline. So what does this thermocline mean? Basically there is a strong decrease in temperature is seen in this layer after 200 to 600 meter depth. So if it's here 25 degrees Celsius, then after 600 or 7 meter, 100 meter depth, temperature drop to 6 degrees Celsius. Okay. So you can you also see the decrease in temperature from the this surface layer to the deep water layer where the deep water layer starts. And in the deep water layer, the temperature deviation was from 6 to 5, okay, 1 degree or much less than 1 degree. Why? There are no energies coming or something. So deep water layer has temperature very much nearly constant. It can be termed as a constant. Even if it's constant, so don't think that you can go there. The temperature is basically very low in the deep water. At 5 degrees Celsius, 4 degrees Celsius are very low temperature. Another thing, you can catch hypothermia. So try to read about this term hypothermia. Okay. Another thing is that when uh, at this depth the pressure of water column is also very high. So that's a quite huge amount of pressure that is exerted into the person which is standing here. So pressure also plays a very important role here, especially in depth of ocean. Okay, so this is the whole phenomenon that you can imagine for the ocean depths, the variation of temperature. Apart from that, I also shown you the variation throughout the week or in the duration of a total week. Oh, so this is a map of Earth. It is a flattened map. Earth doesn't look like this flat. It is a round shape. Okay. So okay. So you can see this temperature is quite low. This is the scale. So with this clearly you can see why, because there is Antarctica here the temperatures are quite low. As you go above the temperature rise, especially near the equator, the temperature is around 30 degrees Celsius or 28 degrees Celsius. Why? Because the heat of the sun is actually more focused on the equator throughout the year and throughout the day. So equator and plus minus 5 receives quite a huge amount of energy. So you can see the variation of temperature is quite normal here. There is not stark variation in temperature, but as you go from equator towards the northern pole or southern pole, you will see that most of the temperature is getting changed from this red color to green color here, green color here. Then it is changed from green color to this blue color. So that is quite a huge stark variation in temperature. So why what can be a reason for this? So basically, what can be a possible reason for this? Because equator, this is basically equator. These are latitudes. These are longitudes. So latitudes and longitudes are here. So what happens when you go up towards from lower latitude like 0 plus minus 5 to upper latitude like 60, 70, 80. So solar energy that is received in the lower latitudes, that is near the equator, is more focused, more concentrated rays are seen there. But in upper latitude, due to the slanting nature of the sunlight, much lesser solar energy received. So much of the ice is actually situated on the pole, and the temperature of the ocean is actually seeing a contrast variation here. So this is the main probable reason of the heat distribution that takes around the whole earth. Not about this, there are various currents that also flow through this region that carries or distribute the heat from the equator to these regions. So this is, those currents are not in the purview of this course, so we'll not go much deep into geography, but we'll see it from a technical point of view or scientific point of view how this temperature is actually varying on the ocean. Okay, so let me see if somebody wants to join. What happened? So no one wants to join. Okay. Seems like somebody must have joined. Okay. So, the way I joined. So yeah, if I think most of you have understood the concept very well behind the distribution temperature, and one important thing which I wanted to share here. So if you see the latitude, where these are latitude, they are longitude. So you see the latitude variation, like variation from this to this upper line. So most of the heat is actually seeing towards downward side on the scale, like from 30 to 10, 6, 8 to 4 something. Okay, but when you go to this is international dateline or 180-degree latitude. So when you go from this to this and this direction, the variation is almost same. Why? Why the variation is almost same? Because at each latitude and longitude, the sun shines with the same intensity. Okay, so sun is actually when sun is overhead 90-degree east, it is overhead at this whole latitude itself. So there must be some slanting. So there is variation towards the longitude, but latitude variation. So same type of variation throughout. Okay. So if this variation is there, almost same type of variation will be seen here also. Okay. So this is one of the good observation which can be derived from this graph. These two graphs are very much important. In exam, there can be a question regarding this thermocline. So you need to answer this question very specifically and with good observation. Okay, so I think this question is actually you guys can easily manage to answer this question. Okay, so moving on to the next question. Let's see if anybody wants to join. Okay, nobody wants to join. The recording is going fine. Okay, so the next thing is ask about the composition of Earth can be determined in part from the formation on how earthquake waves travel through the Earth. So there are three concepts here, three or two concepts here which I wanted to discuss. One is composition of Earth. So what is Earth composition? You know Earth has some soil or some soil like material or rock or pebbles or water or trees, but what is the composition of Earth itself? Like this is the Earth, what it is made of. Okay, and part of information how earthquake waves travel through the Earth. So one is that how earthquake waves, what are earthquake waves, how they travel through the Earth. So yeah, one thing is that this question is actually the statement is true. Composition of Earth can easily be determined in part from information on how not all the composition can be determined, but good knowledge can be obtained through earthquake waves. So this is true statement. Why? See, I will you say you have a material called stainless steel, and then you have a material called rock. So when there are waves which travel through stainless steel, will have some other variation when it is traveled through rocks. There it has some other variation. Okay, so by studying this variation in waves, the amount or the composition of material can easily be determined. Okay, so the wavelength, the variation, the different type of things that can be easily determined through by studying these waves. So this question basically talks about this thing only. Okay, if composition of Earth can be determined in part from information on how earthquake waves travels through the Earth, so it's actually a true statement. Yeah. So I put some pictures also. So why picture? Because you need to visualize these things at your level. To visualizing these things, pictures are very much important. So what are seismic? Seismic is something which is related to Earth. Okay. Seismology. Seismology is a science that study earthquakes. So earth waves, seismic waves. Okay. Focus of earthquake. So what happens in earthquake? There is a focus. Okay. So why this is a focus? So there are plates. There are plates that rub against each other. This is plate, okay, this is P. So these plate rub against each other, and so there can be various movement. It can be like this, it can be like this also, or it can be transverse movement like this also. So there is a point where it rubs maximum. So this is the focus. And the point just above this focus is basically epicenter. Epicenter feels the maximum effect of this rubbing. Okay. And because of this moment of plates and relative to each other, the waves originate. And then these waves actually travel like this throughout the whole Earth composition. So that's why earthquake is here in Mumbai. The effect can be felt even in uh, very long location like Nagpur or in some cases even the Matras also. Okay, so this is the main thing. So try to visualize this picture very clearly. What I am trying to say here, what is basically trying to be depicted here. Now moving to the next slide. So I put a structure of the earth itself here to give you a good idea what earth basically composes of. So yeah. So the first thing which you see on earth is basically called crust. So there is two types of crust. One is ocean crust, that is beneath the ocean, and another is continental crust. So continental crust are something that is on land. So continental crust are basically very thick. They vary from 25 to 30 kilometer, while the ocean crust is quite, uh, can say, not much depth as continental crust. It is basically 3 to 5 kilometers, very depth. Okay. So this whole crust is basically situated on lithosphere, that is a solid. So lithosphere basically varies from 100 kilometer. It has a depth of 100 kilometer. Okay. Then after lithosphere we have a asthenosphere, which is a partially melted form. At the depth of asthenosphere is, so when I'm talking about depth, it is basically this, not the depth from the surface. Okay. So depth of asthenosphere is 180 kilometer. It is partially melted. So you can see here asthenosphere. This one. This is crust. So you can imagine how the crust looks like, how the asthenosphere, how the mantle, the outer core, and the inner core looks like. Okay, so mantle is basically mostly solid, and it has a thickness of 2900 kilometers. Then we have outer core. It's basically in liquid form, 2200 kilometers. That's quite a good thickness, and it's totally liquid. Okay, and the inner core is basically solid. So now the question arises is, if we see the core of Earth, the outer core, liquid, inner core, can anyone say that? Why? Think more about it. Think why this is so. Outer core is liquid, inner core is solid. Even the temperature of the outer core and inner core are very high. So, but outer core is in liquid form. Even after the high temperature, inner core is in solid form. Why? Why this is so? Main reason is basically, both pressure and temperature plays a very important role here. So when you go down the temperature increase, note that the temperature is very high in the inner core and even in the outer core itself. But when you go down, the pressure also plays an important role. So it's a trade-off between pressure and temperature. So here the pressure wins in the inner core, So that why at such high pressure, when the high temperature cannot play a important part, so it is not in the molten form, it is in the form of solid. And just for the outer core, the pressure and temperature, there is a trade-off in which the temperature means the outer core remains in the form of liquid. So this is quite a different structures, or you can say composition. You cannot say it is the composition, it is basically the structure of words. So composition, I will try to uh, leave you guys, so you guys can go and think more about this composition thing. What is the different composition of atmosphere, lithosphere, crust? Okay, so you will get to know different metals which are basically present in this. So most of the outer core basically is consist of nickel and iron. Nickel and iron are very important metal that is found in the inner core. But when you move towards the continental crust type of thing, silicon and other items dominate in this part of the continental crust. So we have this silicon aluminum Cr thing. So silicon is basically very dominant when you try to study the crust, and this aluminum metal is also very much dominant. Okay, so these things plays a very important role when you study this whole composition and structure of Earth. So what happens when the waves travel from the inner part of the Earth to the outer atmosphere, outer like region? So if the waves originated from here, so it passing through the different structure and composition of the Earth, it passes to different metals. The deviation of the waves is actually recorded through different instruments. The waves are basically studied, and the composition can easily be determined through seeing or observing those variation of waves. So yeah. So I will leave you guys with these two slides so you can focus and ask queries. Let me see if somebody wants to join. Okay, so if there are any queries, you can always ask it in the in-call messages, so I can read those messages and discuss those messages essentially. So I'm sure this is working. Yeah.
सर आपको क्रिकेट खाना है?
So if there are no queries, then I think we should proceed for the next question then. So next question basically is asking about cool water from deep inside the ocean can be directly used for air conditioning. So yeah, this is a true. But deep inside the ocean, the obtaining water at such depth is quite a tedious task that has to be accomplished for this air conditioning thing. Okay. So let's move to the next slide and see. So what I was talking about the different variation of temperature with depth, so we see that the first layer, which is surface layer, is actually the temperatures remain mostly constant. But when we move to the thermocline, the temperature is actually getting decreased by quite a steep gradient. The temperature changes rapidly with depth transition layer between surface and deep sea. And in deep sea, the temperature are almost constant, but the temperature is actually very low. So this type of temperature can easily be utilized for air conditioning. Okay, if we are able to get this type of temperature from sea, so these what can be easily utilized for. Okay, so you need to focus on these things only. So if anybody wants to, so in case of deep water ocean, all ocean reach uniform temperature of 2 degrees in the deep sea. Okay, so quite a true condition here. Try to observe this graph because this temperature can range basically very much utilized, and this water can be used in chillers to cool the and utilized for the air conditioning systems. Okay, and let me see. No questions. So try to visualize this figure for a few minutes, then we will move to the next question. So if there are no questions, no queries, huh. OTK is basically ocean thermal based systems. Okay, so okay. So OTK based systems are low in efficiency but can be abundantly tapped. So this is quite a true statement. So we'll see one of the ocean thermal. OTK is basically ocean thermal energy conversion. So basically thermal systems, even the temperature distribution in oceans which need to be tapped are not so much advanced or a lot of research is needed. But yeah, these are very low in efficiency but can be evidently tapped. Why evidently? Because we have a lot of this available. Lots of this system available, water available. So yeah. So one of this system I have drawn here. So yeah, this is warm water intake. This is cold water, mixed water return. So future of type of vortex system. So it takes in warm water, supplies it to the turbine, then it moves. Then one of cold water is actually here. So the difference between those two are actually utilized to supply the convert it to the electricity. So this is how it works. Or in similar terms, even if it's not converted to electricity, it can be used to heat the homes also. Okay. So this is the main usage of this OTEC based systems. So have a look at this slide for a few minutes. Okay, so let me move to the next question then. Let me see how much time we have. Okay, so it's already 8:33 and we need to focus and complete these. We have discussed the non-graded question. Now we will be focusing on the graded question of the previous run of this assignment. Okay, so yeah, we check everything is, yeah, everything is working on fine. So OTIC principle is based on basically ocean thermal energy conversion principle is basically based on the temperature difference, as we have seen in the earlier slides, previous slide, and between the warm water at surface and cold water at approximately 1.5 kilometer. Okay, not less than that. It's not 5 kilometer. 5 kilometer is quite a very huge depth to be achieved here. So it's 1.5 kilometer distance below the surface. So the correct answer is answer B. Now the next question is, if person A and B are moving away from Earth's surface at a location on C, the person A is moving towards the Earth's center and person B is away from it, then the pressure experience will be actually the pressure will be more for A because he is moving towards the Earth. More and more pressure will be exerted on him, and as he will move to away from the Earth, person B, the less column of air is actually pressing him. So whatever pressure we exerts at the Earth's surface is actually how much. This is the surface. This is me. So basically, what happens? How much amount of air is above me exerts a pressure on me. So if I am moving downwards, more amount of air will be exerting pressure on me. So it will be more for A rather than when I will be moving upward, it will be less for B. Answer C is correct. Moving to the next question, what will the approximate efficiency of ocean thermal energy conversion plant if the surface temperature is 373 and colder water temperature is 298? So if we see the temperature difference, that is around 373 minus 298. So how it is going to be solved? So see, 1 minus T2 upon T1. This is the efficiency formula. So just put the values 1 minus 298, and mind it, the all values should be in Kelvin, not in degree Celsius. 373. So 1 minus almost zero point 0.8, so it will be 20%. So the correct answer is answer A. Okay, now moving to the next question. The general concept of a journey to the center of Earth is possible. This statement is actually false. Why false? Because pressure and temperature both increases significantly as we move from center of Earth towards the core of the Earth. Okay, so as we go down, the temperature itself is very high, very high. And the pressure which will be exerted from above will be much more high. Even the Earth's surface will also exert the pressure. Okay, so it's a false statement. Okay, now moving to the next question. Geothermal energy tapped near the forest because there basically geothermal energy very much related to temperature. Okay, so low temperature is not an option, pressure not an option, high pressure not an option. So the correct answer is temperature. Okay, so this temperature is something that actually plays a very important role in tapping this geothermal energy. Now we have to match the water source with additional attachment modification to the plant. So if we see the hot water, it's a basically binary fluid cycle. Why binary? Because hot water can be converted to water and steam. So two fluids, it's a binary fluid cycle. Superheated steam, so directly run turbine, no need of anything. Superheated steam, saturated steam is basically flash tank. Superheated steam is basically steam above the superheated temperature. So answer B is correct in this case. The use of biomass as fuel impacts food production. Statement 1 is true. Because agricultural land is limited, you can go for food or you can go for biomass production. So that's always a good debate going on between what should we grow on our land. For since crop use are not necessarily the same, it's necessarily the same. The sugar cane, the various other crops. For since crop use are same, this can also be. But mostly it cannot be called same like Jatropar. Jatropar are not same. We don't eat Jatropar. For energy production can produce even more food. No, energy cannot produce food. Okay, so food produces food. So correct answer is answer A. Moving to the next question. A banyan tree lifetime is 300 years. If a fully grown banyan tree is burned and a thermal burn to generate energy, a new tree is planted at the same time. The process will become carbon neutral only after many years because whatever is released from this tree will take time to capture that carbon from the atmosphere. Okay, immediate time frame no carbon involved into the no oxygen involved. So correct is it will become carbon neutral only after many years. So it won't impact the carbon generated from this banyan tree doesn't impact the turbine blades are coated with dash to increase dash and to reduce dash of blade. So they are basically coated with ceramics. Okay, ceramic turbine blades are coated, not metal. Metal doesn't have so high fatigue or something. Okay, turbine blades are basically coated with ceramic to increase the lifetime. So yeah, lifetime is basically good, and to reduce the corrosion. Corrosion, something which like rusting or something. Abrasion. Abrasion basically uh, putting damaging the surface through various abrasive particles. Okay, so the correct answer is B and D. If the water boils at 100 degrees Celsius at 1 atmosphere, then at 2 atmospheric pressure, the boiling point will actually increase. Okay, that is the main thing. So when you go atop a mountain, pressure decreases, so the boiling point also decreases. So the food remains uncooked. Okay, you need to cook food for a more duration of time. Why? Because we think water is boiling because the pressure in not 1 atmosphere. At 1 atmosphere, yeah, 100 degrees Celsius. At 2 atmosphere, it will be more. So when you go down, that must pressure will increase and the boiling point will also increase. Okay. So we have covered almost all the graded questions also. So if there are any queries, please feel free to ask. Let me see if there are any questions. So there are no questions from the audience itself. Okay, so let me see how much time is remaining. So almost 5 minutes are remaining. So we have some more slides also to discuss. Like I put these two, three slides. So first I want that you guys should ask any questions which are very much related to this graded and ungraded portion of assignment. Then I will discuss those two slides. A very simple slide that just for your information. Yeah, yeah. Okay, so this is basically the cross section of Earth, which is seen here. Crust is basically 0 to 700. So the temperature, the mantle has a temperature of 1000 degrees Celsius. The lower mantle has a temperature of 3500 degrees Celsius. Outer core 4000, inner core 7000. So you can see the variation in temperature. Okay, And core, so I was discussing about the composition, that's why I put this slide. So you know the composition. Core has basically iron, nickel, noble metal, that's what I said. Mantle has sulfide and oxide rich, and crust are basically oxides of silicon, aluminum, so these type of oxides. Okay, and this is basically a geothermal system. So we have this hot water here, it takes and then rotates the turbine, goes back to the injection well, then again this. So these two are very much separated, not located very nearby. Okay, and then we have generator. So that's how this system actually works. So yeah, thank you for let me see if there are any questions before saying thank you. Okay, so yeah, it's already 2 hours. So yeah, thank you once again for joining this live session, and you can always find me at this email ID. If there are any questions, you can ask in the discussion forum. Also, please feel free to see the videos which are uploaded on my YouTube channel. So links are provided in the problem solving session tab of the NPTEL. Try to log into the tab and click on the YouTube videos. Even you can subscribe my channel. So if there are any videos which are uploaded on this channel can be viewed by you. So that will be a good step by seeing those videos. If you have made this live session, you can easily uh, go through those videos and try to grab the concepts and different questions which are solved here. So thank you once again. We'll meet in the next live session on 11th of April. Thank you.